Hello guys and welcome. I hope that you're having a good day or good morning or good evening. My name is I play 4K, aka I play 8K, aka I play 16K or UHD King. During this video today I'm going to show you enemy front running on 16K resolution rendered in real time, that is 133 megapixels, on a single Titan RTX video card and the old school Xeon E5 CPU, which is 2697 V2, that is running only 4 core 4 threads, 4 physical cores, 4 physical threads, but this CPU is 12 core 24 threads. I disabled in a BIOS to keep my frequency at 3.4 gigahertz constantly. So 4 core 4 threads will be more than enough for this game running at 16K resolution. How I achieve this 16K resolution: pretty much I'm running 8K resolution native screen plus DSR. Today I'm using the Nvidia DSR method, which I think is the best DSR method out of the any methods out there. And today I'm recording this video with Nvidia Shadowplay software on the same computer. So go ahead please and add 3 FPS to the FPS counter to the right top corner. Every second just add 3 FPS to get the FPS without the Shadowplay recording on the same computer in this particular game on this particular system. So let me real quick go ahead and show you the settings that we're going to run today. I know the enemy front is not of the popular game, but it's still running Crysis. It's still running CryEngine 3 that was powering the Crysis 2 game, and let's go ahead and have a look how this game will look like in 16K resolution. This game is about World War II scenarios, but it doesn't have that storyline that's going to keep you in this game, at least for me. I was wishing when I purchased this game that this game going to be amazing, but I think this game would be amazing if it was developed by the Polish software developer. If Polish software developers would make this game as a third view camera game, it would be amazing instead of front view camera game. And DirectX 11, it doesn't matter, DirectX 9 or DirectX 11, in terms of the FPS, maximum +1 -1 FPS, but I believe that DirectX 11 pretty much using some tessellation methods, and the textures looking a little bit better under the DirectX 11. I'm going to show you guys low, medium, high, and very high during this video, and in the end of this video I'm going to show you some information about my computer, and I'm going to show you that my desktop resolution right now is running at 16K resolution with 100% scaling. So pretty much when you're trying to run in windowed mode, because as you can see this is the windowed mode, so when you're trying to run in windowed mode, let me show it to you, any games in 16K resolution, the best way to keep them to have the scaling at 100%. So let me zoom in using the magnifier tool, and okay, doesn't want to zoom in. What's going on here? Let me zoom in. Here we go. And I'm going to show you that we're running windowed mode. As you can see, it says CryEngine 3 over here. This is how small it is, this windowed mode. So this line on top, it's pretty much indication of the windowed mode. Keep that in mind. And the textures in this game is completely ugly textures, and I believe even at the full resolution, at that small resolution, the graphics designer didn't pay attention and didn't make that texture looks amazing, not like in AAA titles. And this is why this game is not going to look good in 16K resolution. When I'm playing Half-Life 2 or any other old school games from 2000 before 2010, and when I'm running them 16K resolution, even if they had 256 by 256 pixel textures or 128 by 128 pixel textures, they're still looking amazing at 16K resolution, because we rendering every single detail of that texture, and that texture at that resolution had the beautiful details. But this is not going to be in case for this particular game, unfortunately, and that's probably why this game is not popular, and that's why this game didn't make it, because developers didn't polish it to the end the way it should be. Okay, so right now it's running completely stock. We're going to start running stock, and then I'm going to improve, and I'm going to overclock my Titan RTX using the software overclocking methods, which is the safe considered by me. But as again, if you're going to duplicate this at home or anywhere else, you're doing it on your own risk and expenses. But I'm going to overclock through the software in a second. So let's go ahead and jump into the game, guys. Okay, I really like how the textures looking right now at this little cross 3D model. It's amazing. We can see every single texture is popping up, but unfortunately it's pretty much, it's not the texture, it's I believe it's combination of two different shaders, and unfortunately this is not how the textures will look like in this game under the 16K resolution during the gameplay. But I wish if the textures would look like in this game like this cross right here, like demonstration of the 3D model that they try to demonstrate. But unfortunately this is not how this game is going to look like. And if they would make this game look like this cross, like this demonstration on small 3D object, the textures will be this type of details, that would be amazing. But nope, it's not going to be like that. So it's low details, guys. I believe with the two Titan RTX and SLI, if this game is supporting SLI, I'm not sure if this game is supporting SLI or not, will be very playable, by the way, at 16K resolution at low preset. But let me show you how the low preset looks like. So pretty much this is how low preset looks like. Okay, let's go ahead and start the game. And you want to keep your eye at the right top corner. You want to keep your eye at the VRAM utilization. Right now we have the VRAM utilization that is below 19,000 gigabytes, or I mean below 19,000 megabytes, or below 19 gigabytes, but it's going to grow when we're going to load the level. The system RAM usage is below 9,000 megabytes. As you can see, the total system RAM usage is allowed on this system 32,000 megabytes, and the total VRAM usage is allowed on this system above 24,000 megabytes. Keep that in mind. The FPS we want to keep as high as possible. The latency delay in terms of milliseconds, which is delay between the hardware and software, such as GPU VRAM, CPU system RAM, and then Windows 10 operating system, DirectX 11 API, and game engine is right now is above 50 milliseconds, which means that game is not going to be under the comfortable mode at all, but it's still benchable mode. And the purpose of this video to bench it so we can compare it with the future technologies, future PCs, future video cards, future CPUs, and etc. Hopefully guys this makes sense. So this is how this game looks like at low presets. Pretty much not bad if you're going to compare low presets 4K resolution with low preset 16K resolution. You can see that 16K resolution and low preset looks much better in this game because the textures are popping. You can see every single detail of the pixels on the textures, but as again, the whole texture quality is not that great, unfortunately, in this game. So 12 FPS, guys. And without the shadow play recording it's going to be around 15 FPS. So with two Titan RTXs and SLI, as you can see, the GPU utilization is 99%, which is the excellent GPU utilization. Means that we wasting almost zero shader cores, or maybe like 5 or 10 shader cores. So pretty much we're utilizing all the shader cores on the TU102 Turing GPU architecture GPU that is powering this Titan RTX video card today by Nvidia. And two Titan RTXs will probably show us around 20 FPS for sure, or maybe even 22 FPS, because if GPU utilization 99%, when two Titan RTXs will be utilizing 99%, it's going to pretty much be almost 2 times in terms of the FPS boost. So pretty much this is how this game looks like. It's going to be 11, 12, pretty much average FPS at 16K resolution and single Titan RTX on, again, old school CPU, Xeon E5-2697 V2. This CPU pretty much as same as 4th gen Intel Core I CPUs if you're going to compare it with the gaming CPUs. So pretty much like 4960X running in stock. This is how this CPU is fast, but this CPU is featuring 30 megabytes level 3rd cache that is shared right now between those 4 core 4 threads, and shared in gigantic amount of the megabytes per each core, and it's going to be a little bit faster than 4960X running in 3.4 gigahertz versus this CPU with the 4 core 4 threads. And as again, it doesn't matter if I'm going to add 8 more cores, we're not going to improve in terms of our FPS, but we're going to decrease the FPS actually, because the latency delay between the CPU core controller while it's verifying will pretty much bring some nanoseconds latency delay, and it will end up to bring us higher milliseconds latency delay and maybe shift off 1 or 2 FPS if I would be running a 12 cores versus the 4 core 4 threads, because as you can see my CPU utilization is below 50%, sometimes reaching like 65%, but still healthy CPU utilization. CPU utilization is not healthy when it's reaching 90% overall CPU utilization and above. That's a clear sign that you would like to add additional 2 more cores at least to have the healthy CPU utilization, guys. Hopefully this makes sense. So let's go ahead and bring it to medium now. We're going to decrease the FPS unfortunately, but we just want to see how the Titan RTX is scaling under the CryEngine 2, under the CryEngine 3 that it was powering as same as Crysis 2. And the details of this game is pretty much in terms of the polygon count for the 3D meshes will be almost as same as on the CryEngine 3 or that is powering Crysis 2. Hopefully guys this makes sense. So this is how the medium preset looks like. This is the details pretty much all at medium. Okay, and that's it. Look like we cannot go lower than that. Okay, this is what's up. Let's go ahead and have a look at this. So went down by 2 FPS lower at medium. Now the texture is looking much better than at low, but still this game, I don't like the textures in this game. The level of details wasn't done for some 3D meshes correctly, and should be much sharper, much more detailed at their texture native resolutions. And I think that graphic designer was, when he was designing the textures, pretty much didn't play a lot on the level to find out how the textures look like. But low doesn't look that bad, guys. As you can see at 16K resolution, even the low quality textures, low resolution textures looking amazing, because like this little back right here that is textured even with the 256 by 256 pixels under the 1080p resolution, probably going to show you about 20% of the details. Everything else will be blurred out, because pretty much a 1080p resolution, that little back will be like 128 by 128 pixels. Maybe 4K resolution going to show you if that texture is 256 pixels by 256 pixels, maybe it's going to render about 80%, 90%, but 8K resolution for sure going to render that little detail of the back at full details of the texture. I'm pretty sure right there, that back's right there, see the details, we can see the bumps on the details. I'm pretty sure if you're running 1080p it's going to be blurred out, and probably even 4K resolution as well, because that little back right there, and with the amount of the textures on that back, the pixels probably going to be like 50 pixels by 50 pixels when you're running 1080p resolution, and maybe like 200 pixels by 200 pixels when you're running 4K resolution for sure, or even smaller than that. Pretty sure everything will be blurred out in terms of the pixel details. 8K resolution probably will show the full details, but everything above 8K resolution for sure going to show the full details. even at the distance of the pixels on that texture, guys. Hopefully this makes sense for those who's wondering if the texture is getting pretty much stretched, and it's not. Instead of, it's going to load every single pixel. Of course it's going to be stretched when you're going to go close to it at 16K resolution, but at the details, at the distance, the level of details when you're running 16K resolution versus 4K resolution is amazing, and anybody could tell. Even on 8K resolution monitor, when you're running 8K resolution native to 8K resolution native, or 8K resolution native to DSR 16K resolution native, anybody can tell that 16K resolution DSR with the 8K resolution native is much more better visuals, much more sharper, and kind of showing you that feel to it, like better visuals to it. And it's not psychological feel. It's I compare two different screenshots, guys, in Photoshop. It is a little bit better in terms of the pixels, the way the pixels managed on the 8K resolution native versus 8K resolution native with DSR 16K resolution native. Somehow it's much better in terms of the details. Alright, so we'll look at that. So of course it's unplayable, but 10, 11 FPS at medium, and at low it's like 12 FPS almost everywhere. We increase our VRAM usage in medium in above 20,000 megabytes, which was almost 21,000 megabytes or 21 gigabytes. As again, RTX 2080 Ti video card or any video card at any Nvidia GPU architecture that having below 24 gigabytes of VRAM not going to handle this game at 16K resolution pretty much, or this benchmark or this test. Okay, so at high, let me show you the details at high. So this is the details at high, guys. Okay, and at very high it's going to be completely screenshots, but at least it's better than screenshots right now, but almost like a screenshots. But I'm pretty sure if we're going to remove the motion blur, it's still going to be much better. And when you're playing low FPS with the keyboard and mouse, it's also, you receive that lag feel to it. But when you're playing the gamepad, on the gamepad, it's handled much better, and lag feel is much less than you playing with the keyboard and mouse. So 6-7 FPS, and as again without the shadow play recording 10 FPS, and this is the high, and looking great at 16K resolution. So without the recording, there is a possibility that with two Titan RTXs, if this game supporting SLI, it's going to be actually playable in around 14 FPS average, as again without the shadow play recording, as again playable like at lowest possible quality, playable like a nightmare status, but still, but as again it's benchable. So hopefully the RTX 3090 will support SLI in this game, and two RTX 3090 will show us playable FPS at 16K resolution at high preset. It would be amazing if it's going to do so, because I'm pretty sure that RX 6090 XT video card is not going to support Crossfire. But if RX 6090 XT video card by AMD will support the Crossfire, it's going to be nice to see that type of video card in 16K resolution as well, guys, don't you think? But as again, different type of DSR methods showing different type of FPS and VRAM usage, and all of the DSR methods that I used, such as German developer DSR method and one more open source DSR method, is not showing close utilization that Nvidia DSR method showing, and I believe Nvidia DSR method the best. I think the Nvidia is mimicking nature of the 16K resolution native monitor as best as it could, because Nvidia pretty much developed the drivers for the Titan RTX. They know what is the resolution is, and I believe and I trust the Nvidia better, because with the different type of methods of the DSR that I tested previously since 2016, the utilization of the VRAM and FPS much different when you running Nvidia DSR method, and much higher in terms of the FPS on the third-party DSR methods, and VRAM usage is much lower on third-party DSR methods when you're running Nvidia DSR method. And I believe the Nvidia DSR is going to be the best when it's going to be emulating the experience of the, in terms of the FPS and utilization, latency delay versus the 16K native screen. Alright, hopefully guys this makes sense. So native 6-7 FPS, okay. Of course it's unplayable, but looking not bad. Look at this. When you're going to zoom in the textures, even at the distance, they're going to be all pop up with the pixels, and they're going to look all amazing, guys. Even when you're going to come to it, it's going to look amazing. But as again, on the leaves, you can see that graphics designer, when was creating the texture, didn't do a good job. And this game can change its visuals if you will use the artificial intelligence or network machine learning, and you will increase the texture. This game actually can, through some modes, can be brought to another level in terms of the visuals. And the storyline is again so-so, but some people likes this game. So not for me though, not for me to spend a lot of hours on this game. But I'm pretty sure there's going to be some fans for this game. Look at the details right there. Alright, so we're going to go ahead and do the very high now, and after this point I'm going to go ahead and wrap it up. But let's go ahead and have a look how it's going to be at very high. As again guys, I'm not going to edit this video. This video is again recorded in 8K resolution native with the Nvidia Shadow Player that was hacked through the runtime debug system memory debugging tool. And all what I did, I just changed the values while the values was stored in the system RAM, and I changed 4K resolution width and height into the 8K resolution width and height in runtime. And this is how it's recording, and it's recording well. It's not stretching, the Nvidia Shadow Player is not stretching 8K resolution videos. It's not upscaling, it's recording in 8K resolution video. So go ahead and watch this video in 8K resolution on your YouTube player. Just switch the settings from 4K or 1080p to 8K resolution to see the level of details, the pixels. It's amazing. But I'm going to switch to very high, and this is when it's going to go ugly on the CryEngine 3 for this particular game. Everything is going to look nice, but in terms of the FPS, we are not going to make it. We are not going to cut it. Even with 2 Titan RTXs and SLI playing, be able to play, if the SLI supported and 2 Titan RTXs will be scaling at 99% to have at least playable FPS. It's not going to happen. But this is how it is, guys, as you can see over here. And this is the level of details at very high preset versus the high preset. I'm going to record this game for you guys in 8K resolution as well. It's going to be a different video, because I would like to pretty much to show you all kind of different experience on a Turing GPU architecture top dogs such as Titan RTX in the game's 8K resolution and 16K resolution, so we can pretty much compare it with the future technologies. As again, this is my purpose. So over the UHDking.com, I'm going to underline Turing GPU architecture, Maxwell GPU architecture, and Pascal GPU architecture like nobody did ever before on YouTube. So go ahead and visit the UHDking.com or iplay16k.com YouTube channel, or iplay4k.com or iplay8k.com YouTube channel. It's going to be a best experience for you. And yeah, let me zoom in. Let me show you how the zoom in will look like. So you can see around 5-6 FPS average, but let me try to zoom in, guys, and let's see. Look at these details or the textures. So this is 16K resolution with the 500% zoom, 116K resolution at the 100% resolution. So look at these details. For those folks that saying texture is scratch, look at this. Texture are not scratch. Texture actually are pulling their details. At the higher distances, you will see the higher visuals, guys. And look at this tree. This tree is highly detailed, I can tell. And at 500%, it just wow. Let's go ahead and try to zoom into it. Look at this. And this is at 500%, so this is above 32K resolution. But 32K resolution, guys, is not runnable under the Windows 10 in 2020, unfortunately. So 400% So this is how it's going to look at 30K resolution if it would be runnable. This is how the visuals will be, and this is how the distance would be at 32K resolution with all these details in terms of the pixels and stuff. Okay, let me zoom out. Okay guys, pretty much I showed you everything what you need to see in terms of this game. So CryEngine 3, guys, as you can see, it's possible to run 16K resolution. It just depends on the power that you have, and you want to equip the video card at least with 24 gigabytes of VRAM. Right now it's above 20 gigabytes of VRAM usage, but below 21 gigabyte of VRAM usage, and the system RAM usage below 10,000 megabytes. That is clear signaling to us that we're running a healthy system RAM usage. We're not offloading any data from a VRAM into the system RAM, so everything is going on pretty healthy over here. But just GPU computing performance is not enough in terms of the VRAM utilization and VRAM on board. We have enough VRAM on board of the Titan RTX video card, but not enough of the GPU computing power. Hopefully guys this makes sense. Let me try to blow this up. It's probably going to generate an extra particles, and it's going to probably utilize a high utilization of the VRAM usage a little bit. So pretty much slideshow and very high for sure. Maybe it's going to be 10 FPS without Nvidia Shadow Play recording at very high with 2 Titan RTXs and SLI. One each Titan RTX in that SLI setup will be scalable at 99%, and both of them will be scalable at 99%. Then probably 10 FPS will be over here as the deal. But as you can see, they didn't do a good job on the gun textures. But as again, it can be fixed with the AI mode for the textures. I'm working on the AI mode for the Quake 3 Arena, guys, called cinematic mode. Go ahead and check it out over the ModDB. With my mode, Quake 3 Arena game will be ready for 16K resolution, and it's going to look amazing. You don't want to miss it. Just Google it, Quake 3 Arena cinematic mode, and visit my ModDB YouTube channel. Maybe I'm going to in the future create more cinematic modes for more games while increasing the texture quality and make them ready for 8K resolution and above. There is a possibility, but this is what's up. And if you're into this game, you probably can increase the quality by retexture the whole game. And of course, if you're gonna do it, VRAM utilization will go up, especially if you're going to use the higher resolution textures. Alright guys, that's pretty much it. Let me go ahead and quit this game. I'm just hoping that RTX 3090 one is going to utilize at 99%, and this game at 16K resolution will show us at 1.8 times boost. Then it's going to be nice. Then if this game supporting SLI, then, and somebody told me that RTX 3090 doesn't support SLI under DirectX 11, and it was long-time subscriber, so I kind of trust him. But we're going to find out. But if RTX 3090 supports SLI under DirectX 11 API, and I still believe that it does, then over here we probably should receive 3.8 times faster in terms of the FPS on 2 RTX 3090 and SLI versus this experience right now. And it most likely is going to be a playable, even at high, very playable FPS, and almost at the comfortable level at 16K resolution on 2 RTX 3090. I'm pretty sure it's going to be around 35 FPS. But as again, or this was guys the workstation. As again, this was my gaming rig, right? It was a workstation, and it was a rendering firm where I'm using this as my secondary computer for the video transcoding, for the 3D rendering, and pretty much for 3D rendering through the network. And I'm pretty sure that my gaming rig, which is gaming rig in 2020, which is i9-9900K, overclock at 5.3 gigahertz on 6 core 6 threads, stable, with 3000 megahertz DDR4 with CL10, 3000 megahertz, will show like unbelievable fast. No, it's CL11, I believe. At 3000 megahertz, I'm using CL11. I believe it's stable, or CL12 on my gaming rig, I forgot, but it's still like very aggressive timing, unheard of timing for 3000 megahertz on DDR4. I'm pretty sure the boost in terms of the FPS on that gaming rig from 2020 on i9-9900K at 5.3 gigahertz, or 10900K at 5.1 gigahertz, which will be the same in terms of the performance. 10900K at 5.1 gigahertz will be the same as i9 9900K at 5.3 gigahertz, and I'm pretty sure that FPS probably will improve by 3-5 FPS as well under the high, not under the very high, but under the high. Under the very high could be improved by 3-4 FPS as well, but not that much. So pretty much this game is totally unplayable at when we're going to talk at playable status with the Turing GPU architecture, and I'm pretty sure it's probably going to be only playable on 2 RTX 3090 NSLI or RX 6900 XT if it's going to support Crossfire at 16K resolution. Alright, so let me show you what kind of system I was running. This is the system I was running. Let me zoom in. As you can see, my desktop is also at 16K resolution, 100% scaling. This is exactly how you want to do it. And 4 core 4 threads, 3400 megahertz or 3.4 gigahertz. And I'm running it on my old school Gigabyte gaming overclocking motherboard from 2014 that I use for 4930K CPU. It's going to be Intel chipset X79. The motherboard will be UD3 version 1.1 by Gigabyte. There is 2 type of version of this motherboard by Gigabyte. It was version 1.0 and this is version 1.1, and only version 1.1 has the F20 BIOS at Gigabyte official website from March 19, 2014. You can download it, flash this motherboard, and then you can install the E5-2697 V2 CPU with the 12 core 24 threads. That is going to be postable and working the way it should be on this motherboard. Otherwise, with any other BIOSes under this motherboard, it's not going to post. As again, you want to have a motherboard version 1.1, not version 1.0 with this BIOS, to make sure you're going to flash it with the i7 CPU like I did, 4930K, and then install, make sure run the Windows with that F20 BIOS, and then install that CPU, and it's going to be postable and pretty much working the way it should be on that Xeon E5-2697 V2 CPU. This is top dog CPU and very complicated CPU from 2013-2014, especially for this motherboard, and that BIOS is required, guys. Okay, F20 BIOS, 32 gigabyte quad channel, 256-bit DDR3 that was running as fast as DDR4 under the 2133 megahertz at CL18 in terms of the stats, but this DDR3 is running 11,030 megahertz, not even 1200 megahertz. This DDR3 is capable to run 1866 megahertz at CL9, but unfortunately nothing is stable on this CPU above 1400 megahertz, and even 1400 megahertz is going to give you a blue screen after 5-7 hours. So this one is 1130 megahertz is maximum stable frequency on DDR3 for this particular CPU running on this particular motherboard, and this CPU is very picky to the frequency and pretty much is going to use lower possible frequency if the DDR3 is not registered. Keep that in mind, and registered DDR3 doesn't have the higher frequency anyways. So as you can see, 7000 megahertz, which was running Titan RTX was running completely stock. When I'm going to overclock my Titan RTX, the FPS in terms of the boost will improve 2-3 FPS at low, and at medium will improve by 2 FPS, at high will improve by 1 FPS, 1-2 FPS, and at very high will improve only by 1 FPS when I'm going to overclock Titan RTX. Okay, and overclock will be, let me show it to you, by additional 1000 megahertz on the VRAM, which will be running at 8000 megahertz, which is because this is GDDR6 times 2, 16,000 megahertz output frequency. Right now it's running 14,000 megahertz output frequency, so I can improve by 2000 megahertz output frequency. And I'm going to improve these values right here, which is the fixed pixel fill rate. Right now at stock it's 169 gigapixels per second, textual fill rate of 509 gigatexel per second, and the bandwidth 672 gigabytes per second. Let me show you what's going to happen when I'm going to overclock this Titan RTX. Immediately we're going to see a big boost in terms of our pixel fill rate, textual fill rate, and of course the bandwidth is getting close, almost close to the GDDR6X, but of course GDDR6X at stock will be much higher value, but very close to this overclock value of the GDDR6. So we are not far away from RTX 3090 video card. Okay, and this is how the Titan RTX and this CPU with only 4 core 4 threads scored under the OpenCL, which is the closest possible emulation when you can compare the GPU versus the CPU. And this is how this CPU scored under IDA 64 version 620 5300. And as you can see, all the values here, you want to keep your eye on the latency delay for level 1 cache, level 2 cache, and level 3 cache, because the bandwidth in terms of level 1, 2, and 3 cache read, write, and copy will improve. If I'm going to add an extra cores, it's going to improve in terms of our CPU, but bandwidth in terms of our DDR3 will be the same no matter how many cores we're going to add. So as you can see, the bandwidth with the quad channel DDR3 running 256-bit per DDR3 is almost the same as DDR4 running 2133 megahertz. Because DDR4 2133 megahertz is running CL18, very high latency delay, so it doesn't help it. Frequency doesn't help it. So you want to balance the frequency with the timing as well, no matter what kind of technology of the system RAM you're running, guys. Hopefully this makes sense. I show you everything what you need to see, and yeah, thank you so much for watching. Maybe I'm going to record on this rendering firm or on this desktop, on this workstation, the 8K resolution in this game as well, but most definitely I'm probably going to record on my gamer rig the same game at 16K resolution, so we can compare same technology but different CPUs, and we're going to see how much the FPS boost actually the 6 years old CPU lost during our benchmark. So if I'm going to record i9-9900K at 5.3 gigahertz, it's going to be nice things to see, because 6 more gens to go, and between the gens, let's say 5 gen versus the 4 gen of Intel CPU, the performance boost was like 7%. So you can 7 times 6, so we're about 50% extra boost should be showing in terms just switching CPUs in PC gaming theoretically, but we're going to see how it's going to be on practice. Alright guys, as again, let me show you my resolution of this desktop real quick for those naysayers that doesn't believe me. Look how small my mouse cursor right here, see that? How small it is. Let me go ahead and zoom in as again using the Windows magnifier tool, and was running the scaling 100%. This is how you want to test games. You want to run 100% for the best possible scenarios, especially when you're running that game in a windowed mode or borderless windowed mode. This is the best way to do it. Alright guys, alright, thank you so much for watching. As again, this system in the middle is going to be my workstation for those who's curious, taking with the iPhone, so that's why when I'm zooming you can see some noise. Okay, DSR not going to show this type of noise. Pixels will be much more clear. And as again, I'm also a professional photographer, but as again, I was shooting real quick, taking that picture. It's still looking nice. And over here on my logo is going to be my gaming rig, which is that i9-9900K. Okay, for those who's curious, my CPU was cooled today with the H100i Pro XT, which is, I believe, 3rd gen of the Corsair H100 CPU coolers, the best, but Xeon is running very cold. And the best scenario, if you're going to run this workstation for a very long time, like 3-5 years, without investing any further pennies into it, to get yourself the air cooler, because the water cooler system will go down, pump will die after 2-3 years. Keep that in mind. But air cooling will last you forever. And this CPU is going to run forever. I purchased this CPU used like new for $120 in the beginning of 2020, and pretty much I recycle all my old parts, and the whole system cost me $120. Why not? And it's almost as fast as i9-9900K overclock on 6-core 6 threads, overclock at 5.3 gigahertz when I'm doing the video transcoding or 3D rendering. Almost as fast, maybe a hair slower, but of course I gotta use the 12-core 24 threads on this Xeon E5 to match my i9-9900K with 6-core 6 threads at 5.3 gigahertz at video encoding, video transcoding, or 3D rendering. But this CPU is going to be like hair slower, but still not bad for $120 value. In the in the end of 2021, you could pick up 2 of the CPUs for around $120, not one for $120, but 2 CPU for $120, and the whole package will cost you around $200-250, including the Chinese dual socket motherboard. And this is how you want to do it if you're planning to do the workstation and build yourself a workstation for around $300 overall, including the power supply case and everything. This is, and pick up yourself like 16 gigabyte of DDR3, $300-350 without the video card. The whole system in the beginning of 2022 will cost you, with the dual socket of 2 of those CPUs with 24 physical cores or 48 threads through the hyper threading technology achieved, and it's going to be pretty much chalking the 4K resolution like at nothing. It's almost doing the hiccups at the 8K resolution, so it takes to render 8K resolution in about half of the day or the whole 24 hours. So it's like 12 hours 8K resolution video transcode to 8K resolution video transcode in about 10-15 minutes. Takes about 12 hours, or 30-40 minutes 8K resolution video transcode to 8K resolution video to lower bitrate. Takes about 24 hours on this system, but it's still nice to use it as a secondary system. So this is how I can utilize and play on my first system without stressing while recording the great benchmarks, because I cannot do the video encoding while I'm doing the benchmark for you, because the numbers is not going to be there. So I'm going to use the secondary system, and this is why I built this system. Hopefully guys this makes sense. Thank you so much for watching. Right now I'm putting some great videos for you to check out. Don't forget to smash that like button. A lot of time, money, energy was invested. Subscribe for more great videos. As again, I play 4K, aka I play 8K, aka I play 16K, or UGG King. Have a great day, stay safe till the next videos.